So the first video is about 3.1 quadratic functions. If you look at your notes, the first page of 3.1 notes kind of give you the summary. We have the general form and standard form, and we will have different way to tell if it's open up and down. If A, the leading coefficient is positive, it's like a smiley face, positive people smile. So it's open up and then it has the lowest point, minimum point here. If A is negative, negative people is usually sad. So it's open down. Because open down, that's the highest point of the parabola, so you have a maximum. For vertex, if you're given the general form, you will do negative b over 2a for the x value, similar to the beginning of your quadratic formula. Once you get your x values, you can put into the functions to get your y value. And if you're given the standard form, then it's going to be h and k for your vertex, or maximum or minimum. And you can see this as the h and k for the vertex, or you can solve for x, and this is your y value, like when we were doing transformation. Basing on that, we also can find the axis of symmetry, which is going through the vertex, invisible vertical line, so it's going to be x equal to the x values of your vertex, and so x equal to negative b over 2a for the general form, and the axis of symmetry would be x equal to h for the standard form. So that's kind of a summary of what's important here. On your actual exam 2, we will give you some formula to help, and the one will be given to you including this. So the formula would be the general form and the standard form, and how do you use them to find your vertex or maximum minimum point. So if you know how to use them, on the test you will be able to use them. Okay, first example for quadratic functions. We are going to give you a quadratic function, negative 5 x plus 3 square plus 7. We know it's quadratic because it has x to the second power. Basing on that, we want to be able to tell if it's open up or down. Why? And also, does it have a maximum or minimum point? And what is the point? So looking at that, and if any time you need to pause the video so you can write down something, you're welcome to stop the video and write down what you need to write down, okay? Alright, so looking at this, it looks like it's a standard form, okay? And because we can tell it's open up or down, because we can focus on the leading coefficient, very good. The leading coefficient A look like it's a negative, or you can say A equal to negative number. Don't just say negative number though, because like you need to say either leading coefficient is negative or your A value is negative. And because of that, we know negative people is usually upset. So you have an open down parabola like that. So open down. And when you have an open down parabola, this will end up as the highest point of the graph. So this is your maximum. So we will have a maximum point. And to find the maximum point, because I asked you to show me some step, you can say the standard form look like this. Ax minus h perfect square plus k. And then my function is negative 5 x plus 3 square plus 7, right? So if I have that, the point, the vertex or the maximum point is going to be h and k, right? So we can see the sign don't match, so it's going to be a -3, and then the k, the sign match, k is 7, right? So your maximum point is h and k, -3, 7, or you can view this as like a transformation. Negative is like reflecting, so that's why it's open down. And then you solve for x equal to -3, and then your y value is going up 7. So you can approach it different way, but you will have to explain your steps to get full credit. So that's the first example. And again, if you need to pause the video and write down something, you're welcome to do it. There's another question for quadratic functions, number 2. We're going to have a quadratic function f of x equal to x squared minus 8x minus 20 is quadratic because it's to the second power, is the highest power, right? So we want to know if it's open up or down. We want to know the vertex. We want to know the axis of symmetry. And we want to know the x and y intercepts. And we also want you to graph it. So this is similar to the quiz question that I gave you. Let's look at this. First, we need to decide if it's open up or down. So we got our leading coefficient A is positive, very good. So positive, people usually smile, right? So we have a smiley face parabola, which is open down, very good. Open up. I say it wrong. Opens up like a smiley face. Okay, after that we need to find vertex, and this one look like it's a general form. So for the vertex, we are going to need look like the quadratic formula, -b over 2a, and once we found that, we can plug it in to find the y value, right? So x equal to -b over 2a, and plug in the number. If you want to, you can stop the video and try to get that part first and check your answer with me. So I can see -b is negative times -8 over 2 times my a, have an invisible 1 here, right? So it's going to be 8 over 2, which is 4 for the x value of my vertex. And then I can plug in a 4 to my function, which we have something square minus 8 times something minus 20, right? So let's see, I need to plug in, sorry about that. I need to plug in a 4 here, and then 4 here, so 16 minus 32 minus 20. 16 minus 32 is -16 minus a 20 is going to be -36. So hopefully if you did it on your own, check this and hopefully it's correct. So for the vertex, my x value for the vertex is 4. My y value of the vertex is -36. Alright. And after that, we're supposed to find the axis of symmetry. Axis of symmetry is an invisible vertical line, so it has to be x equal to a number, right? And that number is whatever the x value is for the vertex, because it's an invisible vertical line going through the vertex, right? So x equal to 4 is your axis of symmetry. For x-intercept, so for x-intercept, we need to set y equal to 0. So 0 equal to x squared minus 8x minus 20. because it's quadratic, hopefully you know that we need to factor or use quadratic formula. And that's why we have the competence exam, right? And the leading coefficient is 1. So you can use AC method, and then you can stop the video and try to factor this and check the answer with us. Or I can think of like two numbers multiplied to 20, and the difference between them is 8. Maybe 10 times 2, and look like the bigger number is negative. So I can double check it, but it's perfectly fine if you want to do AC method, okay? X times x is x squared. Negative 10 times positive 2 is negative 20. Outside we have plus 2x. Inside minus 10x. Together we will have negative 8x. So that looks like correct. So if we solve for x, then x should be 10. And then if x plus 2 is 0, equal to 0, then x should be negative 2, right? So if I want to write them as points, my x-intercept would be 10, 0, and then negative 2, 0, because we set y equal to 0, right? Alright, so those are my x-intercept. Let's do y-intercept. Y-intercept, we set x equal to 0. Alright, so let's see, y equal to 0 squared minus 8 times 0 minus a 20. So basically y is negative 20, right? So if y is negative 20, then y-intercept will be, we set x equal to 0, and then my y is negative 20. So we got a lot of information. I think we are ready to graph. So for the graph, let's think about what we can put on the graph. Like we can put x and y intercept, we have those points. So I have like 10 and a negative 2 maybe here. And then y-intercept is like way out there, negative 20. And then vertex is 4, so positive 4. And then negative 36, or even lower, right? So kind of out of the range, negative 20, 4, negative 36 maybe. Alright, so we're going to connect those points. Like maybe, I didn't do a very good job, sorry. Okay, so I don't know if I can fix that. Let's see. So I didn't do a very beautiful job here. So on the test, please use pencil. Maybe if you make a mistake, you can like erase it and do it again. Sorry about that. And then we're supposed to have an axis of symmetry, which is on 4, right? Okay, so that's how you graph a basic parabola. So this is 3.1 material. Please write that down. If you need to pause video anytime, do that. Thank you.